Thank you for having me here. Please note the disclaimer. Those are beans in the field. We don't have a good beet plot near where I work. So I'm pretty foolish, but I'm not trying to pass those off as beets. I work for the Department of Natural Resources in the climate office. I do a lot of kind of this stuff. I'm really happy to be here. I met Cody and company last year, and it's great to be working with folks who aren't just growing corn. So it's nice to see you all. And I guess one of the questions about aerial application, to the extent that I understood that, your best chance of not having dew and being before the period of lowest relative humidity is going to be 9 a.m. to noon. And if there's more information that we need, I just want to point out we have hourly data that we could help with. And a collaboration between the Minnesota Department of Ag and the North Dakota Agricultural Weather Network has allowed for the expansion of a lot of really high quality weather stations across growing regions in Minnesota, and we could use those data to help find optimal application windows and things like that. So, but thanks for having me. I've got a lot of slides, and mercifully, I won't spend too much time on each of them. We're going to talk a little bit about kind of the recent context, what happened last year. I know it was not optimal in many ways, so we won't dwell on it too much. We're going to talk a bit about trends and variability. And then I've got this big data dump that basically I had provided for Cody last year. Some of it's been updated. And we're just going to kind of tick through those slides. It's a lot of kind of temperature trends just to kind of show you where we've been going, look a little bit at precipitation trends too. The good news is we can talk about the outlook for this year, but it's pretty nondescript. There's no signs of it being excessively wet, but I'll kind of guide you through that if we have the time. And when I say there's no signs of it being excessively wet, what I mean is the long-range forecasters don't currently see anything pointing to that. Doesn't necessarily mean it couldn't happen, but there's no kind of hang your hat on slam dunk for really wet conditions. In fact, if anything, it would tilt a bit dry based on the fact that we're in a La Nina pattern. All right, so just kind of where we are globally, because just the way the global markets affect what's happening here, what's happening with the global climate can affect what's happening here. And the annual, so these are daily, I'm going to stay away from that feedback source. This is called a spaghetti plot, and I think you understand why. It goes from the beginning of the year to the end of the year for a whole bunch of different years. And that orange trace, we're just looking at average global daily temperature for all the sensors at 2 meters all around the world. And you see that orange trace is 2025. It's near the top of the distribution. 2023 and 2024 were the highest on record. So those were really warm years. 2026 is shown that the beginning, that red trace that you see on the left. So it's still warm, but it's not nearly as warm. And in fact, the temperature's kind of dropping relative to what we'd had in recent years. So that's the global average temperature, kind of where we sit as of pretty close to right now. We could do the same thing with the ocean temperatures, and it's the same pattern, basically. 2025 was among, but not the very warmest, and 2023 and 2024 were the warmest on record. 2026 is not as warm so far, anyway, as 2025, and that makes sense because we're in a La Nina. La Nina is where you have cooler water than normal pooling along the equator in the Pacific Ocean, and that essentially has the effect of taking heat out of the climate system. And so it makes sense that temperatures would be lower than where they were. Those 2023, 2024 was a big El Nino year, big El Nino period. So it makes sense that you would have extra heat, even record heat, in the system during that time. This is a graph that you get to, I'm not going to just leave you to figure this one out. I'll help you out here. We're we're looking at every year on record in Minnesota from 1895 through 2025. And we're just taking the combined average temperature for the whole state. So obviously, if you're in northern Minnesota, it would have been cooler than what the dot shows. And if you're in southern Minnesota, it'd be warmer. And also the precipitation for that year. And again, usually southern Minnesota would be wetter than the average. Northwestern Minnesota would be drier than the average, typically. Maybe some differences with this most recent year. And then we're comparing those seasons, those years, to the 20th century averages, which are those axes in the middle of the graph. So on the left, you have cool years, and on the right, you have warm years. On the bottom, you have dry years, and on the top, you have wet years. And 2025 is yet another year that barely, but it lands in that upper right quadrant, meaning, on average, compared to 20th century averages, it was a especially warm and slightly wet year. Again, that's a statewide average. Those of you out in western Minnesota know it was brutally wet. The general tendency has been towards years like that. It's not every year. We have lots of variability in our climate. See all those red labeled years? Those are the top 10 combined wettest and warmest years on record. And they have all occurred since 1998. Now, not every year is warm and wet. You see 2019 there was very wet. It was the wettest year on record, but it was actually pretty dry or pretty cool. And you also see I assume the yellow button, there we go. Some of these years are years in the 2020s that were very warm but pretty dry. But the predominant tendency has been for recent years to be at least one of the two, warm or wet, sometimes both, not always both, and with plenty of variability built in. I mean, not every year, 2024 was a very warm year. It was our warmest year on record. It was also pretty wet with extreme rainfall, especially in southern Minnesota that year. So that's, in a lot of ways, here's the precipitation around the state for 2025. And this should look familiar to a lot of you. I know there's going to be localized reports that are probably bigger than what's on this map, but these are precipitation departures. So if you see kind of cool looking colors or wet colors, those are areas that were wet. And if you see warm or dry looking colors, those are areas that were dry compared to the 1991 through 2020 normals. Basically, the northern part of the state, by and large, was dry. Most of southern Minnesota was wet, and western and far southern Minnesota were very wet. And in fact, even though the departures in western Minnesota are similar to, maybe just covering more area, to what you see in southern Minnesota naturally gets more precipitation on average than western Minnesota. So those departures in western Minnesota are actually a much larger proportional change from what you would normally experience. So relative to what was normal, western Minnesota was by far the wettest part of the state in 2025. And I know some folks in this room felt that. And so that's kind of where we were from a precipitation standpoint. If you average the two together, and this is what it can be hard about being a climatologist, if you average the two together, it's pretty close to normal, maybe even slightly below normal precipitation. But that's obviously not the story that we take home from wherever we live and work, right? And so hopefully this kind of provides some insight to what an almost normal precipitation year actually looks like in real life. All right, so these changes have already been observed, and I just want to point each one of them out. We're not going to dwell on them. But variability, or ups and downs, are part of our climate. They always have been, and they always will be. So what that means is when you hear, we're going to look at some trends, like, oh, it's been getting wetter at this time of year, or, oh, it's been getting warmer at this time of year. That doesn't mean that every year, year after year, it's getting wetter and wetter. It just means that on average, the predominant tendency is to be wetter than it used to be, or to be warmer than it used to be. But there's still all the ups and downs, the variations, the variability that have defined our climate that are built into those trends. And we know this from experience, right? Like most of you have probably observed that the winters just don't get as cold as they used to. But they still get cold. And it's not that every winter is super warm. It's just that on average, they're warmer than they used to be. But we still, currently we're in the midst of what would be considered a cold winter. And it's just that if we look backwards at what used to be considered a cold winter, we don't have much on it. They used to be a lot colder. So on average, temperature and precipitation are increasing. And that on average is really important because it doesn't mean every year. We've been in a clear sort of dry and droughty pattern for most of the 2020s over most of Minnesota, with only these kind of isolated exceptions like western and southern Minnesota last year, southwestern and northeastern Minnesota in 2024. But I mean, it's generally been much drier this decade than the 2010s. But still on average, precipitation is increasing even through the current dry period. I think you all know this. On average, we get more downpours and heavier rains than we used to. That doesn't apply every year. It just means if you look at a whole bunch of years over, say, the last 3-4 decades, you're going to find more of those heavy rainfall events than you would have found looking at the several decades prior. Warmer winters is a clear trend. It's our strongest trend. We just don't get as cold as we used to. That's really what's driving it. And so we don't have as many cold extremes. But combined with that, we also have had increased snowfall, but then decreased snow cover. So we actually are getting more snow on average. Clearly this year isn't a poster child for it yet. Last year and the year before weren't either, but still there's upward trends when we look at how much snow is falling because of how snowy other parts of the early 2020s and the 2010s and the 2000s were. So there's an upward trend in how much snow falls. But because we have warmer winter conditions and more rain during the winter time, we are melting more of that snow, therefore leaving us with less snow on the ground. That does affect things like soil moisture recharge that we are looking for as we get into the spring and the early fieldwork seasons. And I guess the good news for most purposes is that the high temperature extremes are not changing much yet. So as much warming as we've seen in the last several decades, it's mostly been at the winter, it's mostly been during the nighttime, and where we've seen summertime warming has also mostly been at night, and we haven't really seen that much of a high temperature increase during the summertime, and especially summertime high temperature extremes. They're going nowhere compared to history. That's pretty good news. What I think is less good news is that we are seeing increases in humidity. And there's probably multiple reasons for this. We know some of it's just land use practices. We know that some of it's also there's just more moisture in the air because we've evaporated more water off of the oceans as temperatures have increased. So there's just more humidity available. That is leading to higher apparent temperature extremes or heat index extremes. In other words, when it's humid, it's often, on those really sultry days, we're now more frequently in kind of, I wouldn't say uncharted territory, but up at the high end of that intense humidity spectrum than we used to be. And that is driving our heat index values to levels that sometimes were, rare historically, or in some cases hadn't even been observed historically. But the temperatures themselves aren't showing huge changes in terms of summertime afternoons. Okay, this is kind of a snapshot of what all of that looks like. We've added an average of about 3 degrees Fahrenheit to a typical year across Minnesota since 1895. Maybe a little more than 3. But if you break it down by region on the left, you see southern Minnesota has the least amount of that warming, and northern Minnesota has the most. And this is a pattern that actually continues off the map in both directions. Wintertime low temperatures are really what's changing the most, and we're going to look at some data from wintertime coming up here. Northern Minnesota, an average wintertime low temperature, that's the period between December and February, is now on average almost 8 degrees higher than it was at the beginning of the 20th century. If you need help interpreting that, that's a large change. Southern Minnesota, not quite as severe, but still 5 degrees, meaning a typical winter night is now 5 degrees warmer than it had been. And that's just the average over that 90-day winter period. What that means is, probably some days, some years we know are actually cooler than the historical averages, but some of those nights are much, much, much warmer and going to be exceeding those values. And then when you look at summertime high temperatures for June, July, August, those really show very little change. You see northern Minnesota, there is some warming of the high temperatures. There's less in central Minnesota, and in southern Minnesota, summertime high temperatures, actually, this is not statistically significant, but they show a slight downward trend. So when people say, oh, this was the hottest year on record, 2024, we did have the highest average annual temperatures on record in Minnesota, but I don't know if hot is the right word, because it wasn't summer heat that was driving it. It was a lack of winter cold that was driving it. And I think that has bearing on at least some of what you all are interested in and experiencing. So you're going to see a lot of data from this station. I know some of you know where Milan is. Does anyone in this room not know where Milan is? It's okay. All right. Milan's out in western Minnesota. This is probably the best climate station we have in Minnesota. It's 3 generations. They've been doing it since the 1890s, and it's really one of the best stations in the country. Great observers. They've hardly missed any days for the entire period of record. They've been really, really good. So we can look at Milan and do things with their data that we can't do maybe at all the stations in Minnesota, but where we can, we see a very similar pattern. This is the lowest temperature each year. That's those kind of blue dots towards the bottom of the graph, going from 1895 right up through this past winter. And then the upper kind of pinkish or purple dots, those are the average temperature of the 15 coldest days of winter. And so you're looking at, on one hand, just the lowest actual temperature observed, and then you're also looking at the average of the 15 lowest temperatures observed for each year. And whichever way you look at it, you see basically the same thing. Over time, a decreased frequency of extreme cold values and an increased frequency of values that would be considered to be pretty warm given what you're looking at. In other words, so this is the family. Any of you know the Jordans? Do the observations? So Luther is the current observer, or most recent observer, saw a negative 33 low temperature in late January of 2019. In a recent context, that's pretty extreme. But if you look back historically, that used to be fairly common. In other words, what now counts as extreme cold, and by most measures, used to be more common and therefore less extreme. Some of those extremes that we used to see, we just don't see anymore. They're either very uncommon or unheard of now. And this is basically a pattern that we see everywhere in the region. It's the number one way that we're seeing changes in our climatic system here, is through winter warming, and in particular, the warming of cold weather. So we can look at what that's done to the growing season, or what we're really looking at is the frozen season. It's not always entirely frozen, right? But if you look at the time from the first freeze of fall to the last freeze of spring, the window has shortened by 2 to 4 weeks across Minnesota. At Milan, it's somewhere between 3 and 4 weeks. And now you see, those graphs are just individual years, the first freeze date and the last freeze date. And I want you to note the variability. We're fitting trend lines through it. That's a statistical technique that we all learned about back in, like high school or early college math, but it's just an approximation of the change that we're seeing. But you can't take it too literally because there's variations along that trend line in both cases. But the averages First freeze is now about 9 days later, and the final freeze is about 2 weeks or 15 days earlier than it used to be. When we look at how much precipitation is falling in a given year, and then we take all of our stations that have long records, long enough records to do a 70-year comparison anyway, we get 58 stations that can kind of play every single year. And then we just set them against each other. Who had the most precipitation in each year? And you don't know which location it is, we're just looking at that value. But the wettest station in the year, on average, is now over 8 inches wetter than it was 7 decades ago. So there is an increase in precipitation. We could do the same thing, by the way, with the driest station of those 58 each year. You'd still see a trend. Our dry years are getting wetter, and our wet years are getting wetter. On average, we're getting wetter. There's more precipitation, there's more moisture in the air, so there's more precipitation on average that is falling. If we look at our heaviest rains, there's again a long-term trend towards an increase in those. Now, you got to remember though, if we're playing all 58 long-term stations that we have are set against each other. It's like competition. So the chance that any one station kind of wins and gets the biggest value of the year is pretty low. But you do see that whatever that wettest day of the year is, it's on average, it's increased by about 10%, 11%. But there's still plenty of variability in there. A lot of the years, including 2025, but especially, a lot of years this decade, there's not a huge difference between those values and what we saw historically. It's just that some of the bigger values are going up, and we're seeing increasing frequency of 8-inch rains and 9-inch rains, but those are still rare events. They're not happening everywhere every year. Most of us in this room have not experienced an 8-inch rainfall. That is a huge amount of rain. It's just that in our big state, they're occurring more frequently somewhere. All right, so now this is where the data dump begins. These are some thresholds I got from Cody, and we're just going to step through. We're looking, this is Milan, and I'll tell you when we're not at Milan, but we're going to mostly spend a lot of time at Milan. I know there's this slightly favors the southern beet-growing region versus the northern areas, closer to the Red River, but sorry, Milan's the best station we got, and it's hard to replicate some of these stats anywhere else in Minnesota. And I think it's rather representative. You can imagine in northern Minnesota, northwestern Minnesota, you naturally are going to have more cold days on average, but we see the same trends everywhere. Okay? So if we look at the number of days in December and January where the low temperature is 18 Fahrenheit or lower, which is not a remarkable temperature, by the way. But so the first 2 months of winter, really, how many nights get to 18 degrees or lower? You see that there is a downward trend. We've actually lost in that 2-month period about a quarter of those days since 1970. If we look at days where the high temperature remains 18 degrees or lower, so you do not exceed 18 degrees at any point during that day, you see a similarly sharp decrease, actually almost, you're getting close to 50%. So it is a narrowing of the window of cold enough, good cold days. Now we can do the same thing for February, and this is interesting because in my office, we talk a lot about how much winter is warming, but what is winter? I mean, winter is a whole season. And where we see the warming most is December and January. February shows almost no trend. It's effectively not warming in Minnesota. And if anything, February of all the months has become more wintry. On average, this year so far, not a great example of that. Speaking to you on a day where it's going to soar above freezing everywhere in Minnesota. But in general, February's become more wintry while December and January have become much less wintry. And so as a result, those same statistics don't really show a change in February. And if we look at, again, high temperatures remaining entirely below, it's remaining at 18 degrees or lower, we see essentially no trend. So for this kind of first level of temperature analysis, 18-degree days during the winter time, you don't have much of a trend in February, but you've got big decreases in the frequency of reaching those thresholds in December and January. Now let's do the same thing, but for 15 degrees Fahrenheit. Not a surprise. Same thing for January and for the December-January period, or you can look at high temperatures. It's almost the same graph. You've had a decline in both metrics since 1970. In other words, the frequency of really cold, and we're just going to, then we look at February, no real trend. February is kind of like, if you like winter, February's turned into a little bit of a haven month, on average. Also, fun fact, the increased snowiness that we've observed in February has mostly been the second half of the month. We have no idea why that is, but it's something that shows up. It's actually statistically pretty strong. So the number of February days where the high is 15 degrees or lower, also showing, very small decrease, but effectively no trend. Now if we go to 10 degrees, this is going to get repetitive. What the speaker from the climate office did was just showed us a bunch of the same graph over and over again, but with different numbers. But this is hopefully making a point for you that the early winter frequency of these kind of cold enough type conditions has really dropped off. And that's true whether you're looking at the low temperatures remaining 10 degrees or lower, or the high temperatures remaining 10 degrees or lower. And the tendency is, when you are looking at the high temperatures, they have a bigger proportional decrease than at the low temperatures for that same threshold. Then you go to February, big shock, no change. And maybe a very slight decrease, but we've got a lower total count here anyway, so it's kind of hard to make sense of it, but very little change, if any, observed in February. But I do want to point out, as we get to lower and lower temperature thresholds, you're going to see larger and larger drop-offs in the frequency because we don't get as cold as we used to, which means that the number of nights where we get below a certain level doesn't happen as much, and the number of days where we stay below that level also doesn't happen as much. So same thing for high temperatures. Look at that. High temperatures of 5 degrees or lower at Milan have dropped off by 2/3, 67% since 1970. So this is one where we don't like giving credit to our grandparents who tell us it used to be so much colder, you guys don't have any, but they're right. So, you can tell them that. You were right about this one. And then tell them that that's the only thing. And then February, isn't that amazing? February's been really resilient in terms of maintaining its winter identity. You look at that 5-degree threshold, even though it's nosediving in December and January, it's barely budging in February. And that's, again, we see a slight difference if we look at high temperatures remaining 5 degrees or lower. And now we go to the big one, 0 degrees. So this is most Minnesotans, except for if you're from International Falls, 0 degrees is legitimate. That's where we start bragging. Other states, they're whoa, you guys get below 0? It's yeah, 30 to 60 times, depending on where you're from. But that's a big drop-off in the frequency of nights that are 0 or lower, and almost half. And if we look at the days where the high temperature doesn't get above 0, doesn't even reach 0, that's a real drop. Again, the count already was pretty low, so some of these proportions might not be the best way to show it, but it's a big decline, going from around 5 days at the beginning of the period where where the high temperature did not get above 0 to around 1 day per winter now. So that is a big change. And then you look at February. Go February, right? Really not huge changes in the February temperature climatology at Milan. So if we kind of combine all of this, for these different thresholds, basically what it means is the rates of change in the frequency of days with these different temperature thresholds, and I'm just looking at the temperatures overall, so that includes the high and the low temperatures. You've decreased, at a pretty good rate at 18 degrees or less, but those rates generally increase as you get to lower and lower temperatures for January and December. But note that, in February, virtually all of those thresholds either have no change or a very slight decrease in the frequency. So, you are all the experts in what this means for beets and for storage and all of that, but this is, if it helps, just know that so far February's been reliably winter-like, even as the rest of winter has gone through some big changes. And that includes March, which has warmed at a rate that's very similar to January and December, only slightly less on average. So, and November's been warming pretty quickly, so February is this little oasis of residual winter kind of fighting. I like February, if you can't tell. I like winter. We could do the same thing, because that was daily data from, so what the observers in Milan, and we have about 150 similar observers across Minnesota, they use a maximum minimum temperature sensor, and they basically have 2 observations that are made each day usually it's in the morning when they go check. And that's the highest temperature of the last 24 hours and the lowest temperature of the last 24 hours. And that's really helpful. But now we do have sensors that are working around the clock at airports. It's hard to infer some trends from hourly data, but we can look at the hourly values at airports. We don't have an airport at Milan, so we go to Redwood Falls. But it's basically the same thing. Now you can kind of see some of the decadal variation. But the number of hours that were at or below 18 degrees at Redwood Falls show a long-term decline. And this is December and January. And it wouldn't surprise you that in February, they don't really show one, and so I'm not even going to bother. But as you go to lower and lower thresholds, you see the same sort of thing, that the beginning periods, these 5-year periods, had more hours below these thresholds. So you're basically, it's not just that the number of days, hitting these thresholds is less than it used to be, but it's the total number of hours we're spending at 18 degrees or lower, or 15 degrees or lower, or of course, 10 degrees or lower, or 5 degrees or lower, or 0 degrees or lower. We're basically now having as few of those hours on average as we've ever had. In this case, it's a relatively short observation record, but we know, we can match those with longer term trends from other stations. So no big surprise, you're spending less time at cold weather thresholds. Again, the February hourly graphs are inconclusive because there isn't really a change. So I don't want to just flip through a bunch of slides showing a uniform distribution. You can imagine February, we are still preserving the cold weather statistics very similar to what we had 50, 60 years ago. So that's, again, if that's useful to you, it's something that so far has been true. Now, when you look at projections, these are using climate models, and there's lots of caveats with using climate models and making projections from them, but it's like the best tool we have. It's certainly better than, me trying to just sort of guess all of these things that are happening in the atmosphere and telling you what years, 30 years off, are going to look like. But if we look at the nights per year where the temperature is less than 0 degrees Fahrenheit, basically what we see is the historical map on the left and the projected map for the middle of the century on the right. And all it shows you is a continuation of what we've already observed. More decreased frequency. And that makes sense based on the fact that global temperatures continue increasing, so our reservoirs of cold air are shrinking and decreasing. It's harder to import really cold air into the region. And then we melt more snow, which means we absorb more sunlight, keeping our wintertime temperatures higher. I mean, it all does makes sense. So as much caveat as I like to put with climate projections, this one actually works out really well. It matches the trends that we've already observed. And if you go to the end of the century using a really high emission scenario, which I don't necessarily recommend, they show an even more dramatic drop. But I think, if you're planning for I don't know how many of us are planning for the end of the century, but our wintertime climate will be pretty different from what we have now. It'll still be the coldest, darkest time of the year, and we will still be colder than other parts of the country. But, things that seem pretty normal now or typical now in terms of cold weather extremes will be much less common as we get into the future. And in some cases, they won't occur anymore. So the losses that we've had in cold weather extremes will probably continue. And this is just graphical evidence of what I said before, that the highest temperatures of the year really aren't getting any higher. And in fact, the 1930s were just amazing. Everywhere in the whole region, the highest temperatures on record occurred in the 1930s. With the statewide high temperature record for Minnesota actually was set in 1917, but most stations in Minnesota were up in the 106, 108, 110 area in 1936 alone. And there were other years in the 1930s that were extremely warm. But since then, those are just summertime high temperatures. They actually had brutally cold winters because it was dry, because it was a dust bowl, it was drought. So you didn't have as much moisture in the air, so it was easier to get scorching hot in the summertime and then get extremely cold without sunlight in the wintertime. But the summertime high temperatures since that time really show no trend. There is no indication right now that we are kind of getting outside of historical ranges or even heading towards the upper end of historical ranges for summertime high temperatures. That's temperature by any metric. However, I didn't show the dew point, but if we could do the same thing with humidity, and you actually do see a trend. And then when you add on the heat index, the effective combined humidity and temperature, those two variables are increasing. So in other words, we're not getting hotter in terms of air temperature, but we are becoming more humid. And as a result, the extremes of humidity are at times as extreme, and in some cases more extreme than what we had observed historically. So there's some nuance in interpreting some of those summer temperature trends. We're not as hot as we used to be, if you just look at temperature, but if you combine the effects of humidity, which is real, it's physiological, then we are as hot as we've ever been. And I think that issue is probably going to plague some of our projections, which tend to focus a lot on temperatures, and they don't do as good a job of looking at humidity. If we look at kind of western Minnesota region, annual precipitation has increased. We talked about this already. We looked at the wettest station in the year and how that, but this is the same general pattern, general upward trend, about a 20% increase over the last 131 years in Minnesota. So it's on average getting wetter, and even our dry years, look at the dry years of the 2020s, are actually wetter than a lot of the historical dry periods. So our dry years are, in many cases, wetter than they used to be. If we look at the August through September precipitation, same region, there's been an increase during that period on average, but nice, we've tanked here in the last few years. I guess 2025 isn't in this graph. It would be a bit higher because we got doused in August in much of that region. If we go up to the Red River area and the northern beet-growing areas, I do want to point out, this is why climatology can be difficult. I didn't even get to make my joke. Shoot. Usually I'd say something like, well, people always say, how can you do what you do? And you guys are paid to be wrong half the time. And I'd say, no, you're thinking of meteorologists. They make forecasts. I just tell you what happened. I'm always right. But in any case, one of the things that's hard about this is I serve the state of Minnesota, so I can't always drill into every single region and show you what's happening. But those of you in the northwestern part of Minnesota, the wetness trends that I showed for statewide conditions don't apply in the same way. Northwestern Minnesota is only becoming slightly wetter, and if you include trends towards higher temperatures, which as you saw from some of those maps are actually the strongest in northern and northwestern Minnesota, we're on average probably evaporating more water now than we used to in northwest Minnesota. Western and southern Minnesota, it's a little bit different because we've been getting wetter at a faster rate. So looking at regions specifically, but that period, so the annual precipitation, there is an increase over since 1895, although you wouldn't see nearly as strong of an increase if we just look at the last 6 decades. So basically what this means is one of the things shaping this upward trend are these very dry years at the beginning of the record. But if we just look at the period since 1970, there isn't as much of a trend in northwestern Minnesota. And if we look at northwestern Minnesota in August and September, there's very little trend. It's about less than 10% increase, and the amount of total precipitation that's being added there is 0.4 of an inch over a 2-month period, which, if you include variations, that means there's been some really wet August to September periods, including here in, I don't know if that's 2019 or 2020, but a few recent ones. But on average, it's not a huge trend towards wetter conditions. And this is just a mind-boggling, almost like psychedelic graph showing, going back to Milan and showing our annual precipitation and then the amount of that annual precipitation that's coming from days where you have at least 1 inch of rain. That's what the bottom part of that is. And both of these are increasing on average. There's still variability, ups and downs, but on average you're getting more days with heavy precipitation and you're getting more of that heavy precipitation when it falls. And so that is really what is boosting the annual precipitation. It's not that it's raining more frequently. It's just that when it rains or snows, it tends to rain or snow a bit more than it used to. And by the way, it's not like it's flooding all the time in Milan. I mean, they've had actually, any of you who live out in that area know what the actual climate is like. And it's just like pretty much everywhere else in Minnesota. It's on average gotten wetter, but that doesn't mean it's always like catastrophically wet. Last year was kind of catastrophically wet in a lot of that region, but that's not what every year has been like, for sure. So this is, I didn't spell northwestern right, but the differences between northwestern and southwestern Minnesota growing regions are really that northwest Minnesota is getting warmer kind of faster in all seasons than southwest Minnesota in terms of annual temperatures, and certainly in terms of those wintertime temperatures. Southwest Minnesota is getting wetter faster, with the annual precipitation really increasing about twice as fast as northwest Minnesota. So, and then there's just some statistics that we already went through kind of making that point. These are really infrequent precipitation events where you get 4 inches of rain or more. They only happen on average out in northwestern Minnesota. The current frequency is only a few times per century of getting one of those. And the projected increase is to maybe move that up, maybe double the frequency to six or 7 times per century. Bigger changes in southeastern Minnesota. And this again is a projection, but it's also mimicking the trends that we've already observed. These things are still pretty rare. They're not happening everywhere every year, but they have increased in frequency. And this is an interesting piece because when we look at the total severity, total coverage, and total frequency of drought in Minnesota, using normal metrics, typical metrics, we actually see long-term kind of decreases. But this is just one graph. If we looked at late growing season, we would see increases in many areas. If we looked at early season, we would see bigger decreases. So it kind of depends on how and when you look at it. If we looked at shorter term drought, we would see bigger increases recently because we've had these flash drought episodes in recent years. Whereas if we are looking at long periods of drought, that's what's really decreasing in terms of frequency. All right, so in summary, I mean, you probably already know it, but frequency of cold weather days and hours at all thresholds is decreasing, with proportional increases being larger at the lower temperatures. So the colder it gets, the less frequently it's occurring compared to historical normals. So bigger total and proportional decreases. But we don't see any of that. That's almost all concentrated in December and January. And when we look at February, there's effectively no change, whether you're looking at the total number of hours or just the number of days. Precipitation and heavy precipitation are increasing on average. Remember, probably bigger overall increases in southern Minnesota than northwestern Minnesota, but that's also to be expected given that southern and western Minnesota are generally a little bit wetter than northwestern Minnesota. Projections indicate continued increases, but remember there's variability. I mean, we're going to go through dry periods here too. We're going to go through cool periods. It's just that on average, makes perfect sense to extrapolate to a warmer climate and a somewhat wetter climate in terms of total average precipitation. But as we discussed, as you look around the state, even within a year, you're going to see variations that don't just match these general trends or don't just match the story of the year on a statewide average basis. And there's also going to be parts of the year. I mean, 2025 was so mind-boggling in terms of the hydroclimate that you might have forgotten 2024. But 2024 was absolutely bonkers. We had a 30 to 50-day dry spell with almost no measurable precipitation in February and March of 2024. And then we had a historically wet period where it rained basically every 3 days for 10 weeks. Leading to flooding, especially in the Minnesota River. And then we kind of went back into sort of a normal pattern for the end of summer that year. And then we had another 30 to 50-day dry spell in September and October. How well does the summary of the year really explain what happened? I mean, so you have to, this is why don't ever have me come out for like a whole day, because we'll just talk about all these nuances and all these deeper ways of interpreting this. But anyway, that's where I'll leave it. Thank you all very much. I appreciate your time and your attention. And I know I'm standing between you and lunch, but I'm happy to answer questions. I'm sure someone's going to ask about outlooks for the summer. But thank you.
A question for Kenny.
Based on your anticipated CO2 emissions?
So the temperature projections are those come entirely from climate models. So those do have to do with greenhouse gas emissions, and they don't know exactly how much we'll be emitting. So there's a whole range of scenarios. So the really dire scenarios, which aren't particularly realistic, come from the highest amounts that would be plausible to emit. And then the more moderate scenarios are from maybe some of the lowest amounts, and then kind of right in the middle is where we've already been going and where we seem to be going. Yeah, good question. Thank you.
Any other quick questions?